And let's see, it's Monday the 12th. Welcome to Java Programming. We're going to take some questions as well. If I looked at the assignment schedule, I realized I spent too much more time on arrays than I intended to. But we'll try some catching up here, and happy to take some questions. So first of all, let's question about the grading assignment, the test grader homework. What's your question?
The last part was wrong.
The last part of. Let's take a look at that. So if I look at that homework, let's go take it. Chapter 9 exercises. Zoom in on that. It was part 5. Okay, so I stopped in my lecture. I basically came to the point where we figured out the answers, comparing it to the students. All right, did you see that? Let's go to that code over there. And where is that? Here, chapter 9. And down at the chapter, no, that's not the one. Here must be this one. Chapter 9. I have a couple chapter 9s in here. Let's see here. There, I actually have the solution below there. Let's see. Let's go down below here and see. Here's the test grader. And if you haven't seen the video, I basically walked through how we, first of all, read the data from the scanner file. And one at a time, we read a line. Well, first of all, we read the first line. This is where the answer key. We fill in our answer key array. And then for the rest, I didn't create the loop though. I just said, let's do it for the first one. I'm going to let you put a loop around this. Put this in a loop where we keep reading until we're at the end of the file. So I didn't do the looping part, but let's walk through here just very quickly. Here's where we read a line, which is the student's user ID and their answers. So I read next. This just reads one word. What's that? It reads this. It'll read the first part of the line. So I'm assuming there is one string followed by a space that infile.next will read that word. So I'm not doing any error checking. I'm assuming this line has a word in it. Yeah. 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 The trim basically takes leading and trailing white space. Right. Yeah. So that's a handy thing that as I was doing it, I thought, we could assume there's only one space there and skip over to the second letter. But trim is a really nice function of strings.
That's what that trim does, right?
Yep. And I think it removes leading and trailing white space. So if a tab was there, it would trim that off as well, because tab is considered white space. Okay, now in my video I explained that, okay, we're assuming they have answered the first question. If they left a space for the first question, that gets trimmed away. So it's not perfect code yet, but we'll work with this, and then we could modify it later. And whenever I'm doing this with code, if I realize, this might not work in every case, I'll throw a comment in there saying, okay, this is assuming there's not they have answered the first question. Then I can always come back later, reading the code, and say, okay, let's fix this by putting right. And so leave comments to yourself. If you say, you know, I think I can get it to work for the perfect situation, put in comments, say, you know, it may break for this, or let's put in error checking here. Always put in comments to yourself, or someone else that's reading your code, that they took your program, they see you saying, you know, something might go wrong here. That's what comments are good. Not only explaining for what you're intending to do with the code, but you recognize there may be some flaws in it. And you're going to come back later and solve them. So here's the part where I just have a loop. There's our classic looping through the length of the, in this case, it's a length of an array answers. And one by one, I'd use the char at. Remember the char at with strings? That gets me one letter at a time from their answer. And so I could have done this all just using char ats and comparing, but we want to make this an array exercise. So first I fill the answer key. I put that into an array called a answer key. And then the answers for that particular student, I fill in the a answers array with this looping through how many elements I have in the answers array, reading from a character at that position on. So then here's the part where I do the scoring, where one by one I compare, again, going through my whole array, one at a time. I is the index of my answer key. Is my answer key equal to what the answer they gave? If it is, I give them 2. I add 2 to the score, which I have initialized to 0 before I started. And then I'm building up a string just to help me see, am I getting it right? I have a feedback string that shows them what answer they got wrong, and it's helping me to debug as well. Oh, this feedback, I'm just building up a string called feedback. It starts blank. I'll call this initialize feedback for this student. And it's just set to be a blank string. And when I run it, after they've graded the student, I'm going to print the answer key, what their answers were, and what my feedback is, which will show a 2 or a 1 or a 0, or sorry, a dash if they've got it wrong. I could make that an X. You can decide what character to indicate a wrong answer. And a 0 for, hey, they didn't answer at all. They get a 0 point. Since I didn't want to put a -1, that takes up more space, I just put a dash. Now to run this, up in the main, where's my main? I just said, okay, I'm done with my other practice exercises. Just call the test grader program. And so if I run this, the output that I get is the first line is the answer key. The second line is the answers they gave that I read from the file. This is a way to confirm, yeah, I'm reading the right things from the file. And then I show the answers that they got. So if you haven't seen that video, use that. I basically walked through this whole solution, but then I'm leaving it up to you to put this part here of reading one student's answer, have to put that in a loop. And let me show you, give you a little help here. The part that has to be in the loop would be, well, I don't need to do the answer key because I've read that line. I'm going to have to start here, right here. This is going to be the part in the loop. This is going to be the answer they gave. So the loop will start here, and look at that. I put it in a comma. Here's where the loop is going to start. So one thing to do is I need to keep going until I'm at the end of this file. So I'm going to be some sort of a while loop, not a for loop, because I don't know how many lines I have in the file. Yeah, so I'm going to do a while in file, that's the file I'm reading from, dot, let's find out, is there something in there that tells me is there something left in the file? And look at here, the very second method that shows up is has next. So that's what will tell me is there something in my file. And I can make that to be the controller of my loop. Now, where I declare variables and how they get initialized, that's something I'll leave to you to figure out, but that would be the start of my loop. And the end of my loop would be before I print out, well, I'm going to print out the answer key for each student as I go. I can come back and fix that. Let's just go ahead and say we'll do all the students here. And because this is the end of the loop, I'm going to put a comment here. End of file processing loop. And put a little white space there. And here's a wonderful thing about Eclipse. I can do a Control A, come up to here to refactor. No, it's not refactor. It's edit, or is it source format. There it is, source format. And it nicely re-indents everything to make it nice and readable. So in the video, I walked through all this code, so you can always go back and see, look through that and pause it and go back if you need to. But the part about reading through the file till there's nothing more left is starts right there. This is the part I just added. I didn't show you this in the video. But this is an easy thing. I just figure out one student, figure out how to get their answer, print out the results when the one student has an answer, and then throw it in a loop. Let's see if it breaks for me, because I know. Well, let's see what happens to mine. Let's see what I get here. Oh, look, we got it. Looks like one student got all the answers right. Yeah, so it seems to be working. But of course, this is not the final answer. This is just my debugging messages as I go through the loop. I'm going to have to be keeping track of, let's see, I need a line that shows them their percentage score. So as I'm processing a student, I left the comment here. I'm going to have to calculate the score. Actually, we calculated their total points, but we have a summation that needs to we need to turn it into a percentage, right? I think they asked us in the assignment was student ID followed by the answers followed by the test scores. So I guess the answers could be that feedback I give them. So that would work. So I'll let you work on that. Check through the video for detailed feedback. Yes. All right. Quick help. We'll pause for a quick help here, and then we'll go on to the next. What happened to my recording window? What happened to my recorder? Did it stop recording? It's recording. Okay, I don't see my little dotted line telling me it's recorded. That's weird. Well, it may have failed here. Oh, wait, record. All right. Right, so that should not be outside the box. You want that inside of it. I just had the one print. If you look at mine, here's my print. And then here's the end of a while loop. So It's very helpful when you have all these left and right brackets. Put comments at the end of your brackets just so as you're reading through your code later, you know, okay, what does this bracket represent? You see how I put end of my test grader method. That can be very helpful when you want to enter more code. You know where in the world you are with all these left and right brackets. Yeah. No, I think I could consider that if I'm building my program for some limit, but for the way I wrote it, I didn't put that limitation in there because I think that's a silly limitation. No. In mine, as I was doing the code, I'm thinking, okay, I read that string, and here at this point where I actually create my answer key, I set it to be the length of what that line was that I read. So I like that solution better than saying, oh, I limit it to 20 and have some hard-coded, here's how many answers I have. So I think this is a better solution, so I'm ignoring the part about, and even the part here, why limit it to 120 students? Just keep reading till however many lines I have. Okay, I'm going to jump to the new topic because we're a little behind than what I wanted to be when I planned this, but again, I will still take questions, but leave it up to you to maybe send me an email on a question. I can answer you that way because it's crazy how short lecture time gets as we start on topics here. So I'm going to jump to the polymorphism and classes, and as we discuss this, I'm going to get started right away in the homework for Chapter 10. So in Chapter 10 reading, let me show you what additional resources that I've showed that you should be able to get to in the course here. Hey, welcome. In the resources, in the resources, where did I put that? Here we go. You'll see now Malik textbook resources available because in the chapters they have coding sections, and rather than having you retype all those in, those sections, the source code from the book, are right there in Malik 5e textbook resources. You can download all of them as a zip file, or you can just get pieces of them as I've unzipped them on the server as well. So you don't need the whole thing. You're welcome to take all of them and have them for your reference. But you can go to just a particular chapter and get pieces at a time. And for this Chapter 10, polymorphism, and a little bit more on details on classes, they start with a class called clock down back from Chapter 8. So in your resources, you can go to Chapter 8 source code, go to the clock folder, and we can open that clock.java file. And I've downloaded it already. You can download that, and then in your editor, I have an editor here, you can open that in an editor, select all, copy, and then come over to Eclipse and create that clock class. So I'm going to do that right now. I've opened clock.java, opened it in Notepad++, select all, copy, and then back over here in Eclipse, I'm going to go to my Chapter 10 project that I started. So I started a Chapter 10 project. Yeah, the file class clock.java. Clock.class is the compiled version. So I'm not sure why he threw the class files in there. We can't do much with them. I guess we could use them without recompiling them. The clock.java underneath the Chapter 8. We're reaching back to Chapter 8 to get the clock file that we're going to use now as our example in Chapter 10 to build on top of that. So Chapter 8, clock.java. Open that and edit, and just basically we're going to copy paste that into a new class in Eclipse. So I'll go over to Eclipse. I'll just start a new project just to walk you through all the steps, because I'll just start a new project. I'll call it my chapter 10. So say I'm going to do my chapter 10 project. I'll close a few of the projects I have there. Let's just do new. I'm going to start a new Java project, and I'm going to call it, again, use your last name. I'm calling my Manning chapter 10 polymorphism. How about that? We're doing much more than just polymorphism, but that's one of the main topics. And I click finish. Okay. And there's my chapter 10 polymorphism. Before I do anything else, I'm going to add my main class. That will be for testing my code. So I'm going to, after starting a project, right click, new class. This is going to be my main class. So I'm checking public static void, and I'm going to give the name, I'll call it just main chapter 10. Doesn't matter whatever name you give it to that main one. I like to use the word main because it reminds me later that's the main entry point into my code. Does contain static void main, and I click finish. Nothing special in there. This is where we will call our code to test our classes. So I'm going to replace the default comment there with use this for creating and testing use of our classes. See chapter 10 homework assignment. Now I'm going to bop over to the discussion of chapter 10 homework assignment by just going to the course, the listing of activities, homework chapter 10 exercises, and I see in there, I have to turn editing off or I lose lots of space here. Where's my editing? Turning editing on in a course messes up my size here. I have to turn my editing off here in a second. So turn editing off. Where is that? There we go. I have more real estate left. Okay, now back to that assignment. Homework chapter 10 exercises. I'm going to skip the part right yet about drawing the UML diagram, but that will be part of the assignment, is drawing diagrams associated with a particular person, student, employer, and instructor. And we'll be describing that. We'll first talk about a class that's already defined for us. We're just going to use that code that they've given us. We are going to then learn about subclasses by deriving a class called extClock. Well, first of all, let's not worry about that until we get our clock class into our project. Then we'll worry about what in the world is this deriving a extClock class. So come back to our code. We have our main class, does nothing. We can do a system.out.println chapter 10 homework. Nothing interesting yet until we define classes. So in here, I'm going to put define and use extClock class, which is a subclass of clock. So we are going to create subclasses. Yes? No, this is a new one. I'm getting ready to copy. The one I copied is still sitting in my clipboard, ready to start the new clock class. This is only main. I'm just getting ready. Here we go. Here's how we create, and are going to use that clock class that they gave us from chapter 8. Now, rather than figure out how to copy paste code into my project and import it into my project, I'm just going to go through this as though I'm writing it all myself. I'm just going to paste all that code into my clock class. So here we go, ready to create a clock class. I just go up to my project, right click, new class. And in this one, the name of my class is clock. You have to have the spelling exactly matching the code that you're going to write. If you name the file Joe, the name of your class has to be Joe. That's just the rules with Java. If you're making a class, the name inside has to match the name of your file. And I am not creating a main inside of that because I already have a main. So I'm creating the name of my class is clock. It's in my project, and it will create the code inside of my project. So here we go. Once I do a finish, it creates a file, and it just gives me an empty class in there. Well, I'm going to replace this code with what I copied from the Chapter 8 clock class. So I just select through that and Control V. Now I've got the code from Chapter 8, and since it had the same name with case sensitive, I now have the clock class from Chapter 8. Now I'm going to put in comments here just to not plagiarize or just to remind myself this code from Malik Chapter 8 clock class example. And look how he's put lots of comments in there. I'm going to reformat his because I don't like the way his comments are behaving here. I'm going to do a select all and source format. But I like the way Eclipse formats my comments. They're not indented crazy like the other ones. Now we're not going to walk through this class. All we care about is deriving a subclass of clock. And they've told us in the homework here what the name of that's going to be. The name of that clock is ext clock. All right? So let's create a class called ext clock. Here's how that's done. New, oh sorry, we don't want a new project, sorry. New, right click new. Doesn't matter really where I right click. New class. And the name of this class is ext clock. This is where we're going to now create a clock or create a class that is a subclass of the one that we worked so hard in Chapter 8 to create. So now I click finish. Right now, it is just its own little class. Nothing special. It has no relation yet to clock. To make it a subclass of clock, here is the keywords. Extends clock. Now that word extends, that is the key to huge concept here in Java and in most object-oriented languages. Is I have defined a class clock. It has all my code in it that I've worked so hard at debugging and testing. I don't want to rewrite that code. I don't want to make a copy of it and modify it. I want another class that acts much like a clock, but has extra features in it, or just a slight variation in behavior. And the extends word tells me clock, my class called ext clock, it's going to be just like a clock, but just with some extra features. That's what extends is about. And let me show a few little slides that kind of explain that, try to explain that anyway. So here we are then. This is the Chapter 10 topic, is subclasses and polymorphism. The whole reason that we do subclasses is we've already defined some working code. We want the similar behavior, but we don't want to rewrite the code. And it also forces us to be organized into hierarchy. We have parent, general things that is done in this code, and this code in subclasses has all the capabilities of the general class, but additional features. And it's forcing some organization in our code. Now, if you're unorganized in your programming, you can still do really unorganized, horrible code, even with classes. You can make it hard to decipher, but it makes it harder to be less organized because the language itself has this organization built into it. I can write the parent code and never have to touch it again, but I can modify the behavior in my program by making children that behave different from the parent. I can deliver libraries of code that are the parent classes and let the coders that I sell my library to make their own adjustments to it. So I can modularize what happens in the parent classes. We're going to do class diagrams just as a way of making it clear what the parent classes are and what their subclasses do. And there's plenty of free tools out there. And in this homework, I'm asking you to do a UML diagram. You could just draw it in PowerPoint if you wanted to, but there's free tools out there for drawing them online. It's really not super fancy graphics, so you could do it in PowerPoint and just build little boxes with the text in it. And I actually do that in this presentation. But lately, I've been playing with YWorks. I have used Lucidchart quite a bit, and that's built into, if you have a Gmail account, it was an app that came with Gmail or with Google Apps. Here's typical class diagram where I have a teacher class that I have defined in this example, and the thing that's different about a teacher compared to your regular person is the teacher has a department name associated with them. Now, we could say, well, okay, our fine CIS students, you have declared a major. Well, that may not be your department name. That might be your major declared. So a student may be a person that has a major name that is different in their class. So we could have a student class. Anytime we have membership or members of a class, you have typically those setters and getters of the properties of the class. When a class is a subclass of a class person, the class diagram points from the subclass to the parent class. And what that arrow means is there is a dependency. This teacher is undefined without knowing first what a person is. So a teacher extends the person class. And every person in our code has these members and methods. Just very general members and methods. And this is described in Chapter 10. I made this up as an example of a subclass of the class person. Now we've gone already knowing how to define classes and memberships and or member items and methods. The subclass just extends this whole idea of objects that I don't have to rewrite a person class to make a teacher. I can just say teacher is a person, meaning the teacher inherits all the members and methods of a person with additional or variations on existing methods. I can rewrite methods in my teacher class, such as get first name. Suppose teachers, they have a different way of putting a professor in front of their first name automatically. I can rewrite the set name function without changing the person class. That's called overloading. I can rewrite that. But this idea, this relationship, a teacher is a person. Now here's just part of the code for the person class, is that I have a first name and last name as properties, members of the person, and here's how that person is constructed. There's the constructor. In the teacher class, it extends the person class. I have this wrong. This is extends, not inherits. Let me fix that. The teacher class, in the terms of describing the class, we call it inheriting, but the actual code says extends. So we use the term inherits in our code. That's the same as using extends. Okay, so let's go back then to our code. We want to have this class extClock extending the clock class, but what do we want it to be have extra beyond just a regular clock? Well, let's see in the description. In the description of the homework, we have, where did that go? We have we need a data member to store the time zone. Okay, so we're not making a huge change. We're just adding time zone to our clock. Now, if you're writing this code, you might just say, hey, every clock should have a time zone. Let's just modify clock. Well, for some reason or other, and in this case, just to practice how polymorphism works, we're going to add it to the subclass. Maybe the clock class has been frozen in code control, and the boss says, no, we are not changing the clock class. But in your application, you realize, wait a minute, we need the time zone because we have international, this program we're writing is going to have international people from all over the world. We need to know what time zone there is. The boss says, no, we wrote it just for Iowa. We're not going to change the clock class. Well, because we have this capability, you can say, okay, since you're not letting me change the clock class code, I'm extending it in my code. And nothing breaks. The people that sell and are controlling and maintaining the clock class, nothing has to change there. You don't have to go through any politics to get them to change their code. You can extend it. Right, right. You're writing the child. You're in complete control of the child. The parent, you don't have to touch the parent at all. So that's a great thing. It's modular. They have their code. They don't have to fix it or change it. I have mine, and I can change mine. If they break the parent class, mine will be broken because I depend on the parent class. But that gives you the capability of extending existing code without rewriting it or making a copy of it. The copy of it means if they update and enhance the parent, I never get those benefits. I have to recopy everything. You don't want to do that. It's just prone to errors. So that's the modularity. Okay, so we are adding a member to store the time zone. Okay, well, let's add a member to store the time zone. Let's just call it, let's see, would it be a string? What's your typical information about a time zone? Let's think about this. Add a time zone member. How should we define time zone? Integer? Now, when you look at time zone, what is our time zone? What time zone are we in right now? Okay. What is Central Standard Time? There you go. So we've got a name. Central Standard Time, and we have, yeah. So we may want to store it as more than just an integer. The integer could be minus or plus from UTC.
So we'll add UTC, and then from that
Yeah. Well, when we're actually doing time calculation, where we get the UTC time from some time server out on the internet. So let's just go ahead and we could do it as simple as possible. Let's just say, let's call it, well, it's going to be an integer, right? It's not fixed. There's no time zone that's not an integer offset from UTC. So let's make int, how about we call it UTC offset. And since I like to go by the name, actually there's two parts, isn't there? There's string, let's call it string abbreviation. CST, UT, mountain time, is it MNT? CPT. There's lots of different names for the abbreviation. And let's call it string full name. Central Standard Time. So I've decided maybe 3 things would be good to use. Now I could actually make that an object. Some people might think, oh, all you really need is the UTC offset. Well, just to be nice and complete, I'm going to add those 3 versions, those 3 extra members to my extension of the clock class. And now what do they want us to do? Basically, write the definition of the methods and the constructors. Well, we need a new constructor of the clock class, of the ext clock class. So let's just make the default constructor public ext clock. This is how we define our default constructor. And might as well put in comments default constructor. Here's something about subclasses. There is a clock class, and let's look at the clock's constructor. The clock default constructor is to set my time to be 000. So there is a set time in the clock class. ext clock automatically calls the superclass default constructor without me doing it. And what we call that is implicit call to super dot constructor. It's in there. But if we want to make sure that it's called in a particular order, you can actually call it, oops, even though you don't need to, you could add to your code a call to the constructor with this simple name, super, empty brackets. I can explicitly call the constructor of my parent by using the word super. You don't need to though, but you're not kept from doing that. Now before doing anything with our extended time zone capabilities, let's just test this and see how it works. So I'm going to save this. I'm saving the clock, and there's my main. Let's do something interesting in our main. Right now, all I'm saying is Chapter 10 homework. Let's make a new clock, or a new extended clock. Let's say ext clock, my clock equals new ext clock. And I think there's a toString built into this to my clock. Let's just find out. Let's do system out println clock, or sorry, my clock colon, and then my clock. I don't have to say dot toString. Automatically, if I am trying to treat this like a string, it will automatically attempt to use the toString function. That's just built in to how Java behaves with objects, because objects have a default toString built into them. So I'll put in parentheses that's automatically calling the toString. Notice I didn't have to say myClock.toString. I could if I wanted to, but I don't have to. Java will automatically look for the function that returns a string. Let's run and see if this actually works. See what I get when I do the toString. ext clock, add an address. Wait a minute. Shouldn't it say something like what time it is? Well, objects automatically, every object that you have, every class that you ever create, already has a parent called capital O object. It's already there for you. So I see that in my clock, they didn't define the toString, so it uses the parent of that object toString. And the default toString of any object, if you haven't defined toString, basically just says the memory address of what that reference is. That's what that number is. It shows what type it is and where what the memory reference is. I'm going to change where my colon is here. But we want a better toString than that, so we are going to rewrite the toString for our ext clock, or supply a function that replaces the default parent object, just tell me what the memory address is. We're going to rewrite toString and then see how it behaves. So let's go back to our ext clock. And now, again, I'm going to put end of default constructor. What do you want to go back to? Oh, back to main. Oh, here. In main, all I'm doing is calling my clock. By default, it calls the toString. I find out that clock doesn't have a toString, that it's using the default object toString, which means tell me its type and its memory address. And see what I'm doing? I'm writing the code. In the main here, I'm writing a little bit of tests. Let's see what we get when we use that ext clock. So go back and forth from my class definition to testing code just to verify it works the way I expect. So now we're going to write the toString. So I'm going to put in here replace. Basically, we're replacing the toString. We're defining our own toString function for our extended clock, because that's what subclasses can do. You can replace or fill in where they don't have one. So what does a toString look like? Well, it returns a string, so I better have a string. toString takes no parameters. And what am I going to do? I'm going to return, well, let's see, I want to get my hour, minute, second, and that's what my parent has, HRMINSEC, but they're private, so I can't access hour, minute, second because they have been made private by my parent. Yeah, but I can't get at it. I can't get at it by the hour, minute, second variable name because they have been made private. I have to use the getters and setters of my hour, minute, and second in order to read or change hour, minute, and second. I don't know why this is hovering on. Because my parent has made them private. Private means, sorry subclass, you can't see this. You're just like any other code. You cannot get at the hour, minute, second variable. But if you want to see what they're set to, you can do a get hours, get minutes, get seconds. And that's what we're going to do in our toString. So let's look at our ext clock. I can return, let's go ahead and do, let's see, how do I get at my parent? How do I get at my parent hour, minute, seconds? My parent is a clock class. Well, what's my parent's name? No. You're right about it. Remember, super. super.get. I refer to my parent always by super. If I did clock, I'd be referring to a method of a abstract clock class, but it wouldn't get my particular instances.
What if I had multiple variables?
I can only refer to my initial parent, I believe. That's a good question though. If I have multiple inheritance, I'll check on that. But for this one, I can do get hours, and then I put a. Are we running out of time already? Oh man. Okay, so we'll rewrite the toString. I'll continue next time, and send any questions you have. Read chapter 10. They do a lot more in depth on polymorphism, a very important concept. See if you can complete this. Basically, you're going to do the get hours, get minutes, and get seconds to display to get a toString of your extended clock. You're going to basically add the time zone to the end of hour, minute, second. Yep. Well, I'm building a string, and I don't have to have them on one line. I could do this to make it a little easier to read. And I'll call it, I'm just going to put the abbreviation of my time zone. You know what? I'm going to add TZ to that. Just make it clear that's my time zone abbreviation. I just decided to give that a different name. And of course, I'll set my time zone to be Central Standard Time. For my default constructor. All right, I'll be continuing this on Wednesday. All right, see if I can get this recording stopped and upload it here.
This goes directly on Moodle or in your YouTube?
I'm sending it to my YouTube, and I have a link to my channel on the Moodle. All right, let's see. How can I get this recording stopped?